How's it going? Sorry, I'm trying to figure out why my video is not showing up. Hmm. Oh, that it's a bit further away. Hey, how's it going? Good, good, good. Okay, sounds perfect. Yes. Uh, so- Hello, students.
Okay. Welcome to People's University Marine Biology. This is class 4 already. And next week, I did find a professor finally for the invertebrate cephalopod class on octopuses, squid, nautiluses, cuttlefish, etc. Her name is Theodora Motz, and she's a PhD student. I'm sorry, I have a cold and I'm a little out of breath. Scripps Institution of Oceanography in San Diego. So that's next week at 7. And this Tuesday, if you're interested, St. Patrick's Day, Fairmay will be here to play Irish music at noon. Our instructor this evening is Nicholas Tucker. He is a postdoctoral researcher with the Gulf Ecosystem Initiative, working on characterizing thresholds, effects, and potential displacement or attraction of cetaceans, which we'll be talking about tonight, due to anthropogenic expansion, specifically through marine artificial structures like oil and gas platforms, artificial reefs, pipelines, aquaculture, etc. As an avid researcher of foraging ecology and predator-prey systems, he's curious about how habitat use and movement might overall affect foraging behaviors. His previous work emphasized remote sensing, particularly with scientific echo sounders to quantify aggregations in the water. This includes studying the environmental effects on acoustically insonified pelagic communities. Try saying that 3 times fast. Such as zooplankton, squid, and fish, describing the relationship between demersal preyfish and the critically endangered Rice's whale, and describing habitat use of minke whales in the western North Atlantic in conjunction with prey availability and potential predator risk from orca, killer whales, all of which were components of his dissertation research at Florida International University, where he received his MS and his PhD. So here is Dr. Nicholas Tucker.
Well, thank you so very much. That was very kind. Well, hello everybody. Welcome. Thank you so much for showing up and listening to me yap about marine mammals. Can everybody hear me all right? Okay, perfect. And is the presentation showing a cute little seal? Excellent. We're already halfway there. All right. So welcome today. We're not just going to be looking at your run-of-the-mill sea creatures. We're going to be looking at some biological reversals. We're going to be talking about some animals whose ancestors decided to leave the ocean for the land, and then they turned right back around and they said, you know what, that's pretty good. I'll go back. So before we get too deep in, I just wanted to give you a little bit of background about like some of my expertise in marine mammals and like my history on them. I know that we've already kind of addressed some of that, so we'll gloss over it. But in general, I'm the son of retired Master Chief in the Navy, and so I grew up all over the West Coast. Nominally, I had these orcas in my backyard in the Puget Sound of Washington. This is a very famous pod. We'll talk a little bit about them later on in the presentation. But then right after I graduated high school, I went to Anchorage, Alaska, where I got my bachelor's of science. There, I worked with some researchers looking at stellar sea lions, which is another marine mammal, particularly sea lion aggregations off the coast of Russia, and how their haul outs might have affected the local nutrient regions or local nutrients in the region. After getting my bachelor's, I went back to Washington and I ended up working as an intern for the Sandpoint office in Seattle. You can see Mount Rainier in the background, just kind of standing proud. But here I was working particularly on fin whale calls. And in
I
particular,
can't do
fin
it.
whales have something called a 20 hertz downbeat. That's the kind of call that they make, and it literally just sounds like whoop. But it's very interesting. It was very tedious work on my end. I ended up having to look at the computer for a very long time.
Hey,
Uh,
Nicholas, I'm sorry to interrupt. Can you
no
make
problem.
your PowerPoint slide bigger? I think you have it. Maybe you have it on, you know, the wrong view. It's
Oh, do
sort.
you guys have the reviewer or the
Yeah.
viewer or the presenter views? Is that
There you
better?
go. Yeah, that's much better.
Oh my gosh, I'm so sorry. Hopefully that helps. Okay, excellent. So after working there for a little bit, I ended up working as a groundfish fisheries observer back in Alaska. While I was there, I did a lot of research with an endangered species of whale, the North Pacific right whale, and they are very similar to the ones that are on the Atlantic coast, which we will talk a lot about toward the end of our presentation. And then I'll gloss over this part because it was in my introduction, but effectively during my dissertation research, I worked with minke whales in Saint-Pierre-Miquelon, which is a French territory in the western North Atlantic, and of course the Rice's whales, which, if there's time at the end, I will happily go on and on about. But one thing I really want to point out that's important for these guys is that they are the only resident baleen whale in the Western Hemisphere. That means that they are not migrating at all, which is a very strange behavior for baleen whales. They don't tend to do that. And there's only 50 of them left in the wild. So it's a very endangered whale, very, very important for the local ecosystem. And then lastly, I'm currently here in Santa Barbara, where I'm continuing work in the Gulf, specifically looking to see how marine artificial structures like artificial reefs, oil and gas platforms affect how whales, dolphins, and porpoises react to their presence. And that could be for good or for bad. Sometimes it brings the prey in, which brings them in. Sometimes the sound makes them go away. So let's get into it. Marine mammals. So we like to break marine mammals up into four distinct groups. Probably one of the most famous ones, these are the ones that I work on, are cetaceans. So cetaceans include whales, dolphins, and porpoises. These are some of the smallest marine mammals that we'll find, but these are also some of the largest marine mammals that we'll find, including the blue whale, which is the largest animal that has ever existed in the entire history of Earth. Um, and so it is a very, very large group of animals. There's also a group called pinnipeds. These include seals, sea lions, and there's one individual within the walrus family. It's just the walrus. And we'll talk a little bit more about like the differences between those two a little bit later on. There's something called fissipeds, which are just sea otters and polar bears. And then lastly, of course, we have sirenians, which are the dugongs and the manatees. Well, there's actually only one dugong, but there are three different species of manatee. So first off, before we begin, We want to remember that even though they live in the ocean, they're not fish. They might look like them, they might have very similar aspects, but this is what's known as convergent evolution. And instead, they are fully mammals. And so that means that they have to breathe air. They are coming to the surface at some point if they're completely marine or if they are even beaching out, like at some point they have to breathe air. They are also homeothermic and this or homeostatic, which means that they have to maintain the same internal body temperature throughout their entire life. Now, all mammals will have a internal temperature between 36 and 40 degrees Celsius, and that's 97 to 104 degrees Fahrenheit. For most marine mammals, it does tend to be closer to 100 degrees, but again, there's a lot of individual variation depending on where they live and what their requirements are. The other trait that all mammals share, and especially marine mammals have, is that they have fur. And a lot of people don't think that animals like whales or dolphins, which look very smooth, don't have fur. They do. It is just very small and is very translucent. But in general, this fur is important to help with insulation, especially for some of those cold weather mammals, they need that as like an extra a layer of thermal regulation. And then, of course, we have production of milk. So all marine mammals do produce milk. They have mammary glands, just like all other terrestrial mammals. They're This milk is especially nutrient dense. So for these animals, because they have to exist in an environment that would be otherwise very challenging, this milk is very good for having a lot of fat in it and a lot of nutrients, and it helps those baby cetaceans or pinnipeds grow really, really, really fast so that they're able to feed themselves. And then, of course, they bear live young. So there's actually only one group of mammals in the entire world, terrestrial or oceanic, whatever, that doesn't have live young. They're called monotremes. But all marine mammals, all of them have live young. And it's interesting because in most mammals, their young are born head first, but because they have to breathe, marine mammals are born tail first or breech. So, what does that mean when we say evolutionary U-turn? So this evolutionary U-turn is in regards to how these animals had evolved from their prior ancestors coming out of the ocean, and then immediately turning around and adapting back to living in a fully marine or aquatic environment for the rest of their life. And so here I have an image of what the Earth looked like about 55 million years ago. This was classified as the Eocene geological epoch. And so we're going to start today with cetaceans. They're some of the oldest marine mammals to have evolved. But one of the things that I'd really like to point out to you is how much extra water space there is, especially around like the tropical areas and subtropical areas, but even like Russia has been bisected by ocean. And so this is just to kind of point out that during this time, animals had to adapt to a completely different lifestyle. And so one of those animals was something called an Indohus or an Indohyus, depending on. And it was this kind of cute, almost rodent-looking furry animal. It was completely mammalian at this point. And it had grown up alongside rivers, streams, and coastlines. And during this time, it had spent so much time along these coastlines, it had developed kind of an amphibious behavior. And over time, and especially when you're looking at this left-hand image, we can see that the Indohus has evolved this longer tail. This tail begins to flatten as we get down here toward this 40 million years ago, 45 million years ago time period. And at the same time, we start seeing the reduction of those hind limbs. So a lot of people think that the tails of whales, dolphins, and porpoises are just the fused hind limbs, but in reality, it is their tail. Their hind limbs end up becoming so small that the bones no longer generate. There are a couple of whale and dolphin species which will have something called vestigial pelvises, and this is a situation where the bones are so small and floating within the tissue that they barely exist. The other thing that occurred with this lengthening of the tail is the flattening of it. So flukes evolved around 35 million years ago, and this is where these large cartilaginous tissues had evolved out of the sides of the tail, allowing the animal to swim more efficiently. And so this is cartilage, just the same way that your ears and your nose bridge are cartilage. And one of the things that I think is really interesting is that the Indohue also has another descendant. It's not just dolphins and whales, but it's also the modern day hippo. These modern whales and dolphins are actually very distant cousins of hippos, pigs, cows, camels. Those are their terrestrial cousins. Um, Also, a pretty old animal, evolutionarily speaking, is the family group of sirenians. So this includes the dugong, which is native to Australia, and then a few species of manatee, which are located mostly in the tropical, subtropical regions of the world. So these animals evolved approximately 50 million years ago, which on the in terms of geologic scale is not that far behind cetaceans. Um, but unlike cetaceans, these animals share a common ancestor with modern day pachyderms, so like elephants and tapirs. Um, Interestingly enough, though, when we look at how these animals' body shapes have formed over time, we can see that they followed a very similar evolution as cetaceans did. And that's where we see the lengthening of the body. We see the tail becoming longer as well and flattening out toward the end, creating flukes. And we see the recession of those hind limbs into the body. Now, both cetaceans and sirenians have also evolved a number of other adaptations, and we will talk about that in the next few slides in order to make living in the ocean environment a lot more habitable. But I put a little cute picture of what an old Sirenian might have looked like. Next, we have pinnipeds. So these folks only evolved about 24, 25 million years ago. They evolved from an animal known as an arctoid, which is a common ancestor to modern day bears and mustelids, which is very interesting, giving our final and fourth group. But I have an example of what that animal looked like down in the lower right corner. It kind of looks like a wolverine. But what we notice is that these pinnipeds are morphologically very representative of what it looks like when a carnivore goes from living on the land to living in the ocean. You can almost think of pinnipeds as that in-between state from when cetaceans or manatees were evolving into the ocean because they have these very noticeable hind limbs still, and their tails have not started to lengthen quite yet. And so it's kind of like we caught them in the act as they're trying to evolve to adapt into the marine environment. And then finally, we have fissipeds. So there's only two animals in this group. It is sea otters and polar bears. Obviously, there's other versions of bears and there's other versions of otters, but these two animals in particular, sea otters and polar bears, have adapted to living in a marine environment or using the marine environment so much so they are considered ecologically a marine mammal. Interestingly enough, the sea otter evolved about 12 million years ago. Um, and like I mentioned, there are other otter species, but there is only one kind of marine otter. It is the sea otter. And then for polar bears, they only evolved about a million years ago, and they are apex predators in their environment. An apex predator is an animal that has no other animal eating it. It does not have to worry about running from any other animal at any point in its life. And that's because these animals are pretty voracious. An adult polar bear stands upwards of 18 feet tall when they're on their hind limbs, which for reference is 6 times the height of an average human. Very, very, very big animals. All right. So one of the things I find very interesting about marine mammals is if we think about evolutionary time in millions of years, and compare it to how long the animal spends their day to day in the water, we get a pretty clear idea of what that has done to their body types. So, for example, for cetaceans, which include the whales and the dolphins and the porpoises, they spend exclusively all of their time in the ocean. At no point do they come out on dry land, and if they do, they will die. They have completely evolved a fully aquatic lifestyle, and they are not just found coastally, but also far offshore. Sirenians, on the other hand, are also exclusively marine, but they are only found in coastal waters or even in rivers. And so this tells us that evolutionarily, they're not quite adapted to those offshore or those deep water environments. And then we have pinnipeds, which spend some amount of time on land, and that is called a haul out, actually. But they are so well adapted for living in a marine environment, and that's why they kind of look the way that they do. But they also evolved more recently. And then lastly, of course, we have our sea otter and our polar bear, which live about 50% or 30 to 70%, depending on land, and the rest of that time would be spent on the water. I just think that's very interesting, so I thought I'd make a quick little graphic for you guys. So, what makes living in the ocean an option? And so I would like to talk a little bit about some of the adaptations that these animals have had to undergo in order to live in an aquatic environment and to do so successfully. So an adaptation, just if you weren't aware of what that is this modification of a specific trait over time. So adaptations and evolution go hand in hand. As an animal is evolving, it's developing these changes in traits in order to make them more successful. And then that trait gets bred into the next generation. And so over the course of millions of years, we see these adaptations really showing up. So, for example, if we wanted to go swimming in the ocean and we weren't a strong swimmer, we wanted to swim better, we might get things like the hand fins or the regular fins that you would see on a scuba diver. But for marine mammals, especially ones that have spent a lot of time in the ocean, we see completely fused fins or flippers. There's no visible bones or bony or like digital separation between the bones, anything like that. And that's very, very obvious for this humpback here in the first kind of column. For manatees, which evolved a little bit later, we can see very clear depictions of fingernails. It also looks very much like an elephant's fingernails, which makes sense since they're cousins, right? And then lastly, we have sea lions and seals, which have very obvious separation between their bones. We can see that the webbing is still there, but we see that these limbs have lengthened and they've adapted to being broader so that it's easier for them to maneuver in the marine environment. And lastly, I have the forelimbs and the hind limbs of a sea otter, where you can see that this is almost like a dog or a cat paw. There's some webbing there, but it is not as far down the evolutionary track as you would see in like a seal or a sea otter, or sorry, a seal or a sea lion. And then same for the hind limb, where we see it's starting to flatten out, but there's still a very obvious toe shape to those hind limbs. Some other ways that they've adapted to living in a marine environment is based on how they breathe. So, in order for them to come to the surface and take a deep breath, mammals have evolved the ability to be conscious breathers. So, as you're going about your day to day, you don't even have to think about it. If you're driving to work, you're breathing. You know, when you're asleep, you're breathing. For marine mammals, it's a completely different story. They have to decide when to breathe and when not to breathe. And so when they come up to the surface, they have developed these very strong muscles around their nostrils, and that compresses it tight enough so that the water cannot intrude. And when they come to the surface, they have to open them up really quickly. They eject all of that air, and then they quickly breathe in so that they can recycle their oxygen. And so I've provided a couple of examples on how, from humpback to this seal, to this dugong, to the polar bear, on how those different nostril shapes have taken place just based on those animals. And what I also find very interesting about respiration marine mammals is they don't necessarily have bigger lungs than us. There's actually quite a few marine mammals whose lungs are smaller than us. They're just more efficient at storing oxygen. So in the graphic down on the bottom, it kind of shows this, but marine mammals are able to exchange 80 to 90% of their oxygen in a single breath. Humans, on the other hand, are only able to exchange like 60 to 70% of their oxygen in a given breath. In addition, their rib cages are collapsible. If we collapsed our lungs, we would have something called lung barotrauma, which would involve a trip to the hospital and a lot of surgery. For them, it is an adaptation that allows them to dive deeper, either because they're avoiding predation or they're trying to find some food. But the benefit of this is that it also allows them to avoid nitrogen reabsorption. So, for any of you in the audience who have ever had a scuba diving course, one of the things that humans have to worry about when they go diving is something called nitrogen narcosis. And that's basically where they get toxic poisoning from nitrogen being in the system for too long, and how that gas bubble expands and it causes even more problems. For marine mammals, they've adapted to collapse their lungs to reduce the chances of having those effects. And then lastly, they have higher levels of myoglobin, which is a part of the blood system that controls how much oxygen is available. And so the myoglobin in marine mammals is exceptionally high, and this means that they're able to store oxygen for longer. And so what this means is that marine mammals have adapted to being able to dive deeper and be underwater for long periods of time. And so in this graphic, I've shown a couple of the record-breaking whale dives that have been recorded so far. And the thing that absolutely boggles my mind is this Cuvier's beaked whale down at the bottom, where it reached a depth of 9,800 feet, and it was down there for 222 minutes, which I try and hold my breath and make it about a minute. And these guys are down there for a very, very long time. And most of that is, again, trying to find food, avoiding predation, or perhaps there's some other new behavior that we haven't been able to discover yet. Some other interesting adaptations is if you're living in the marine environment for long periods of time, you have to be able to feed yourself. And so marine mammals have developed a broad category of different feeding strategies. The most common, of course, is your standard conical tooth shape. And this is really good for grasping onto slippery prey, such as squid or small fish. Alternatively, there's things like this on the right-hand side, where you've got like the front canines, which are good for picking up and grasping crabs, but then their molars have these very strange nodules on them. And this is called a crab eater seal because it specializes on consuming hard-structured animals, mostly crabs, but sometimes some mollusks. Down here in the middle, we have a skull of a manatee. These animals are adapted for a completely herbivorous diet. They only really eat seaweed, and so they have flat, crushing teeth, mashing teeth, which is perfect for breaking down the seaweed before they swallow it. And then lastly, we have baleen. Um, I've mentioned it a few times, baleen this, baleen that, baleen whale. I'm very, very fascinated by this kind of adaptation. Baleen whales have evolved the ability to move beyond a basic tooth shape, which is made out of dentin and enamel, and they have something that is instead made out of keratin. Keratin is the same protein that your hair and your nails are made out of, and baleen is this structure that is suspended from the upper jaw of the animal, and it acts like a sieve. And so what they'll do is they'll make a big foraging gulp. They'll engulf prey, water, whatever they can get their mouth around. And then they use their tongue to push all of that excess water past these baleen. And then the small animals get trapped in the baleen. So krill, small fish, small squid, things like that. Once they've done that, then the whale will kind of lick the prey off and it swallows it and it goes for another round. And so these baleen plates are divided up into sections and they can hang quite a long distance. The average length of a baleen itself is somewhere between 3 and 11 feet long. But in the bowhead, it can go all the way up to 17 feet long, which again, that's almost the height of a polar bear. I just think that that is insane, especially for the bowhead not even being that long of a whale. I'd be remiss if I didn't also include the narwhal, the unicorns of the sea. These animals are very, very fascinating. That's not actually a horn growing out of its head. It's in fact a tooth. This tusk is a spiraling tooth that grows out of the upper lip of the narwhal. It's either the front left or the front right tooth. And it is a sensory organ. It is very innervated. That means there are millions of nerve endings within the tusk, and it allows the narwhal to sense changes in water temperature, pressure, and even salinity. It's also used in sexual selection and dominance. So males will often use it to spar with each other, either for competition, but they've also been observed doing something called tusking, which is basically where they will rub their tusks together, and it seems to be a form of strengthening social bonds. And then lastly, of course, there's been some drone footage that shows that male narwhals, sorry, will use their tusks to tap and stun fish, kind of like how a swordfish uses their bill. And I think that that is fascinating that they've grown that adaptation out of their teeth. One of the other challenges of dealing with living in a marine environment, of course, is dealing with the high heat capacity of water. So water is really good at stealing the heat from you, and marine mammals have evolved counteracting this by either having a lot of fur or having really fatty tissue. So in the image that I provided here, it's a cross section of a sea lion, and we can see that they have chosen both paths. They've got a very dense undercoat, which is kind of this soft, downy material, and that creates a layer of air between the outer coat and the skin, and this insulates the animal during long dives. And then, of course, they have that outer coat, which is more water resistant, waterproof, a lot more oily, and that helps again kind of protect that inner layer from getting wet. And this helps sea lions, seals, and other more furred marine mammals stay in the water for longer. It's kind of like a dry suit. And then the alternative is that they could have blubber. So blubber is a very fatty tissue. It's a lot like the fat layers that we might have on our bodies, except this one is more dense. And the way that the tissue itself is structured is that it is capable of retaining heat a lot better. And so between these two adaptations, they have been able to stay underwater for longer. One of the things that I think is very interesting about fur in general is that here we have an example of a sea otter. Sea otters have the densest fur of any animal, and they have upwards of 850,000 to a million hairs per square inch. Comparatively, humans only have 800 to 1,300 hairs per square inch. So this is extremely dense hair. And if you've ever had the opportunity to go to an aquarium that has sea otters, or if they have a sea otter pelt, I highly suggest that you try and feel it because the sensation of it is very, very strange. It's like rabbit fur, but on a whole nother level. Um, and so one of the things that really stands out about this is they've clearly adapted to staying in water for long periods of time. And if humans tried to stay in the water, if the water was only 70 degrees Fahrenheit, we wouldn't really make it longer than 2 to 3 hours. After that point, we would enter a danger zone, and any longer than that, we would definitely die. So for animals that have evolved for living in the marine environment for a long period of time, they've done an outstanding job on it. So with all that, I've tried to do some comparative physiology between humans and marine mammals and what that looks like. And so I thought it would be kind of funny if I was like, okay, well, what would it look like if humans decided to evolve into marine mammals of a sort? And so here's what most people think of, standard mermaid, of course. But in reality, this isn't quite it, and we'd probably end up looking a little something more like this guy right here. So with that, marine mammals have developed this ability to move around quite a lot. Particularly for some species, they will make massive global migrations, sometimes spanning from pole to pole or from equator to pole. Now, oftentimes for whales, this is the rule less than thus then the exception, as I mentioned. There there are two whales that do not really migrate, particularly two baleen whales that do not migrate. The one is here in the Gulf of America, and then the other one is the one in the Indian Ocean over here. But other than that, whales are highly migratory animals, and they will go to the northern reaches or the southern reaches toward the poles in order to feed during the summer months, and then during the winter months, they will go towards the equator so that they can calve. For pinnipeds, they spend about 50% of their time on average on land and the other 50% in the water. Again, there's a lot of variability depending on what animal you're talking about or even what individual you're talking about. But in general, pinnipeds will spend the summer and fall in aggregations on rocky beaches or outcrops. And this is again called a haul out. And here I've shown an example of walruses doing just that. In the late spring and summer, these animals will migrate from the Bering Sea into the Chukchi Sea, which is in the Pacific Ocean, through the Bering Strait. And I'm going to go back just one so I can show you exactly where that is on the map. So they're going from, ooh, I don't know where my mouse is. There we go. So they're going from here in the Bering Sea up into the Chukchi Sea, which is just north of Alaska. And then lastly, of course, we have our Sirenians. There did used to exist a Sirenian called the stellar sea cow. Unfortunately, it's gone extinct, but it was the only boreal species of Sirenian. All of the current living, otherwise known as extant Sirenians, all live within these tropical, subtropical waters. Around the Gulf here, the Amazon manatee lives obviously within the Amazon River basin. West African manatees are coastal along the western coast of Africa and into the wetlands there. And then, of course, we have the West Indian manatee, which has made its way around most of the East African continent, India subcontinent, and Indonesia. With that, I think I'd really like to talk a little bit about how incredibly intelligent these animals are. So many people hear the word marine mammal and their first thought is Shamu or like the dolphins at SeaWorld, which is completely fair. I think they've done a great job marketing those animals. But what I think we should really highlight is how incredibly intelligent they are. So I've shown an example of a dolphin brain on the left-hand side of this image here, and you can see how different it is from the human brain, which is on the right-hand side. It is much larger and it is much more complex than the human brain is. And so this suggests to us that they're able to develop very intense tools, language, culture, and society. And of course, this is the example for the bottlenose dolphin. There's more variation across other marine mammals, but there is a consistency that marine mammals tend to be incredibly smart. And the other thing that's really cool about this graphic is that there's four dolphin species which have shown that their encephalization quotient, or otherwise their intelligence, is upwards of 2 times more than things like chimpanzees, gorillas, and orangutans. So just imagine if they had fingers, how much better they could sign than Coco the gorilla. One of the evidences that we have to support how intelligent these animals are is, of course, tool use. So here I've shown a sea otter. Sea otters are known for keeping rocks accessible. They'll either keep small ones in their little tiny pouches that they keep under their armpits, or they might use a big rock. They use these in order to smash their favored prey, which is usually mollusks like clams, oysters, and mussels. We can also see here, since I talked a little bit about bottlenose dolphins and how smart they are, we can see something called sponging, which is in the marine mammal science community actually a relatively new thing. Researchers in Australia noticed that these animals would carry around sponges on their beak, and they were like, "What is happening here? Why are they doing this?" And what they found out was that they were using the sponges in order to sense along the seabed in order to find prey, which I think is really incredible stuff. Some other ways that they have shown us how intelligent they are is through the use of foraging specialization. So one of the most iconic and memorable ways that humpback whales forage is through something called bubble net feeding. And this is where one or two individuals will swim in tightly concentric rings around some bait. And during that time, they will release bubbles of air as they go in a circle. And as these bubbles rise to the surface, these bubbles are going to get larger and they become more ebullient, which means that they just become more crazy and erratic. And this frightens the fish and condenses them into tighter aggregations. And so once those whales have done their circles, their friends, whoever else is in the pod, will come from underneath and they'll take these big gulps of the prey that have been concentrated in a tighter circle. Another evolution from marine mammals that I find rather interesting is echolocation. So many people assume that only bats are the ones that can echolocate, but dolphins and other toothed whales have developed this ability too. And echolocation is basically where these animals have something called phonic lips or monkey lips, and they're just two organs that are compressed tightly directly underneath their blowhole. What they'll do is they'll push air up from their trachea up past their phonic lips, and it echoes against this organ in the front of their head. This organ is called a melon, and it's very fatty tissue. And what it does is, as the lips behind are vibrating, the melon amplifies the sound like a speaker does. And it sends out this fast chirp directly into the water column in front of it. And as that sound wave travels through the water, it bounces off whatever is in front of it, for example, a fish. And as the sound wave echoes or bounces off of that fish, it comes back toward the dolphin's face, or other toothed whale, and it hits the jaw, and the jaw is um, very sensitive to different pressure waves. In fact, they've got something called an acoustic window, which is a portion of their jaw which enables them to interpret this sound. This goes back up to the dolphin's brain, and it gives it a pretty good picture of what it is in fact chasing. All right. Oh, sorry. And I had this little guy on here because there has been evidence, of course, of dolphins fishing with humans and alongside humans in order to improve their chances of catching extra fish, which I think is kind of funny. Um, Culture within marine mammals is very well defined. For as long as we've been tracking individuals within populations, we found that most marine mammals tend to have a matriarchal structure, and this means that there is largely the grandmother at the head of the household, and then you've got the daughters and their offspring moving kind of along with the nurses on either side. Males tend to be more individualistic, although young males will of course stay within a pod or a population. And so I've shown an example of a pod, which is a pod of orcas from Vancouver, British Columbia area, which is different than the one that I showed at the beginning with the J pod. The other thing that I found out recently, that I think is so interesting about humpback whales is that their culture is transmissible. So humpback whales are known for having these very long, complex songs that can last hours. And what this researcher, Dr. Ellen Garland, found was that they will send their songs um, through transmission of other male humpbacks across the South Pacific basin. And so here, just to orient you to this little plot, we have East Australia, New Caledonia, Tonga, American Samoa, Cook Islands, and French Polynesia. And these are areas or regions within South Pacific that move eastward across that basin. And over time, we can see that portions of these songs filter through and are sent along, just like we have different pop songs kind of filter throughout our culture. And so, if you're interested after today's presentation and you want to see more of the different kinds of sounds that marine mammals make, I highly recommend that you try out Voices in the Sea. Um, this website is really nice. You click on the species up here in the top, and you can listen to what humpback whales sound like. You can listen to what gray whales sound like. I highly recommend you listen to what Weddell seals sound like. They sound like descending spaceships. They literally go woo, 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 woo. It's very, very entertaining. All right. So one of the things that studying marine mammals has made me very aware of is that they are confronted with challenges every single day, every single decade, every single century. And so one of the things that affects them most, particularly polar animals, is loss of sea ice. This is challenging for both seals and polar bears because in order for them to survive in such a challenging environment like a polar region is that they have to be able to take breaks. If you're swimming at the pool or at the beach, if you're spending a lot of time in the water, you know how tiring it can be swimming for long periods of time. And so as we've lost sea ice, as we can see here in this image from 1985 to 2025, we see how little ice there is within that region. And so either ice not being strong enough to support the weight of an animal or it being too far apart really contributes to the loss of these populations. Another example is how irresponsible boating, such as people going out on a boat and they're not obeying the boating speed limits, or they're going off track, or or even the high volume of nutrients that end up leaking from septic systems can really contribute to negative effects for marine mammals. So here we have an example from Biscayne Bay, which is close to where I actually did my graduate research. We can see how seagrass beds have changed over 5 years alone, how they used to be completely abundant here in the middle of the bay compared to this, which is a lot more sparse and harder for the manatees to access. So this contributes to starvation, which is, of course, not helpful because then instead of focusing on making new manatees or growing bigger and stronger, they're just trying to find food to forage on. Probably more local to West Virginia, and the East Coast in general is the story of the North Atlantic right whales. So does anybody here know why why right whales are called right whales? No? Well, it's because they were the right whale to catch. So during whaling times, they were a lot easier to catch than most other whales. They swim very slowly, they live very close to shore, and when they die, they end up becoming positively buoyant, which means that they stay floating at the surface, making harvesting a lot easier. And so as of the late 2025, early 2026 time period, there are approximately 370 to 380 North Atlantic right whales within the eastern seaboard area. These endangered species do face a high risk of extinction. There's probably fewer than 70 reproductively active females of that 375 approximately whales left. Um, and so I just wanted to show some of the struggles that they faced on a chronologic scale. So here we have April 10th, 2025. We can see that there's an animal that has some fishing gear entangled in its mouth. Here we have two animals. Both of them were relatively young with entanglement gear, with fishing gear entangled on their body. The lower one, you can see the researchers were trying to help remove some of that fishing gear. Uh, there have been recurring updates as of February this year. It does still have some fishing gear attached to it, unfortunately, but they were able to remove some of it, which is good. In December of last year, there were two more whales entangled. The one in nope, sorry, just this one's. And then in January, there was this one other one that was observed having an entanglement. And then lastly, of course, we had unfortunately a mortality event in February where this young female, she's 3 years old, was found um, that she had been dead, but the cause of death was listed as an unusual mortality event. And these events are usually caused because of boat strikes, or if this animal had been entangled for a long period of time, lost the entanglement, but still ended up washing ashore. So some of the other challenges that marine mammals face, of course, is pollution. Pollution is not just limited to the fishing detritus, such as fishing gear that entangles them, but it could also be things like plastic, large bits of plastic, as you can see in most of these images on the top left corner and kind of surrounding it. Obviously, that is physically visible why that is such a problem for them, but also something that's endangering marine mammals globally is microplastics. So microplastics are not good for anybody, including us, but it is especially bad for them because it tends to go directly to their blubber. Because most plastic is something called lipophilic. That means that it's attracted to fatty tissue. And most of these plastics contain chemicals that can leach into the body and they will cause disruptions to hormone regulation, which will cause a whole host of other problems. It can also just cause physical damage. It's like having a splinter, right? Like if we were to get one, that would cause localized inflammation. It would become very painful. And so we see that occurring a lot with these marine mammals too. And then lastly, one of the other things that is really harmful to them is the tendency for boat strikes to occur. So, according to the International Marine Mammal Project, over 20,000 whales are killed by ship strikes each year. And so here you can see how a fin whale is draped across the bulbous bow of a container ship. This is devastating to see because it's a completely preventable situation. And unfortunately, there's a lot of friction between the people who kind of say this is how we can solve the problem versus like this is what's more important to me. And I do want to point out too that pollution is not limited to physical. Noise pollution is something that has been known to affect marine mammals as a very um, vocal animal. They're very capable of producing sounds, but they're also very sensitive to sounds. And so if they live in environments that are constantly perturbing the environment, either through boat noise or through drilling or something like that, it will affect the way that they're able to find prey, if they're able to rest, reproduction, et cetera, et cetera. And it's estimated that in some areas, like vessel noise has reduced that area for whale use by upwards of 90%, which is a little factoid in the bottom right. And so with that being said, I ask, okay, well, why should we care? Why, you know, what is the point? Why should we care? And it's because marine mammals are important. Many marine mammals are keystone species. A keystone species is an animal with which, if they didn't exist, the ecosystem would not be the same. And so here we have an example of sea otters, which are notorious for being keystone species examples because without them, the sea urchin populations that co-occur in the same area would completely devastate the kelp forest, and that ecosystem would become barren. Basically, look like after a wildfire or something like that. Um, there are also many marine mammals are also sentinel species. So sentinel species are early warning indicators of ocean health and environmental hazards. And although there's a whole slew of different kinds, the one that I exampled here is the manatee. So manatees tend to serve as indicators of harmful algal blooms, such as brevetoxicosis, which is derived from a cyanobacteria, and they indicate if environmental degradation in coastal habitats is occurring. And the other reason why they're very important, whales in particular, actually, is because they help cycle nutrients. So for deep diving marine mammals, such as this humpback whale that we can see here, it goes down to depth where it will forage on its prey. And when it comes to the surface, what goes in must come out. And so it's able to provide a whole lot of nutrients to those surface layers. And those nutrients immediately go into helping support phytoplankton, which is the foundation of the entire marine ecosystem. Most people think that the oxygen that we breathe comes from the Amazon rainforest. And although that's true, almost the entirety of our oxygen actually comes from these phytoplankton. A very, very important part of the global ecosystem, not just the marine one. Some other reasons why these animals are important is, of course, because from an economic perspective, they contribute to tourism. Many coastal communities are very appreciative of the marine mammals that live close by because it increases the tourism in that area and it helps keep those communities stable. And likewise, they're important for that cultural reason. For my own experience with the Pacific Northwest, with many of the local Suquamish tribes, orcas are such an important part of cultural identity, but also across the globe, when we think about Australia, Aboriginals they have stories of working with the local dolphins and orca communities in order to fish. And this is something that's been going on for 10,000 years. And they have an oral tradition to support that. And so I don't want to end on a really sad note. I would rather end on a little more of a positive note. So I'd like to just kind of address some of the positive things that have come out of marine mammal conservation. And so the Marine Mammal Protection Act was a law that was signed into being in 1972. And this law protects all marine mammals, and that includes whales, dolphins, seals, sea lions, manatees, sea otters, and polar bears, of course, walruses, and that's within U.S. waters. And so, since it came into law, quite a few changes have occurred, including we've seen an animal that we thought was extinct actually rebound, and it continues to grow every year, such as the northern elephant seal. We've seen the Guadalupe fur seal, which was slowly recovering from the brink of extinction, and is now a rehabilitated species. It's now considered threatened instead of near extinction. Um, the Hawaiian monk seal has surpassed 1,500 individuals for the first time in 20 years, and nearly 30% are alive today directly due to conservation efforts led by NOAA and their partners. Um, in 2022, we saw humpback whales entering San Francisco Bay in significant numbers, and each year more continue to return to feed and to rest. Also, we've seen gray whale recovery. The eastern North Pacific population rebounded also from near extinction, and they were actually delisted from the Endangered Species Act, which I think is really cool for them. In Vancouver Island, Canada, there were 89 sea otters that were relocated from Alaska to this area. And because of these conservation efforts, their numbers now number over 8,000. And this reintroduction has actually helped to restore the local kelp forest. And again, of course, reducing those sea urchin populations. And then lastly, of course, we have Dominica, which is a country in the Caribbean that has established the world's first reserve for sperm whales to protect their habitat. And we're seeing sperm whales localizing on the island because of those protections. And so I leave kind of one last final thing with this conservation idea is that if this is something that is interesting to you, if my presentation today has inspired you in some way, you can always contribute as well. Best thing to do is, of course, contact local reps. So I've put your representatives and your senators on there for you, and just advocate for the policies that you like, and talk about really upholding or strengthening the Marine Mammal Protection Act or the Endangered Species Act. But you can also do small things like within your own house. If you are a tuna eater, try and choose dolphin safe tuna. These are initiatives that try and reduce marine mammal impacts while while fishing for tuna. You can also join organizations. The Marine Mammal Commission has a great page. It's not comprehensive. There's lots of other ones out there. But they've got a lot of resources where you can actually help support marine mammal conservation. And then, of course, I know West Virginia is a little bit more on the landlocked side, but if you are an active boater and you do go into areas where marine mammals are present, it's just to be a responsible boater or support other people who are responsible boaters. And that just means following the federal guidelines, make sure to minimize vessel strikes on whales and other marine life in general. And with that, I just leave you with a few final thoughts that marine mammals are extraordinarily diverse, with lots of interesting adaptations. They are found globally, and some of them are moving around quite a lot. They're very intelligent animals, very social animals. And even though they struggle to keep up with global climate change and other human-derived problems, they're very important to us for ecological, cultural, and economic reasons. And so if there's anything you can do to help with their conservation, I really hope that you do. But otherwise, just appreciate them for what they are. And with that, I'd happily take any questions from you guys.
Okay, we have time for just a couple questions, so you guys know the drill. Raise those hands if you have a question, and I will come to you with the mic. Anybody?
I have a question.
Yeah, what's up?
Next week we're talking about octopuses, and we've learned a lot about their intelligence recently. But it's a different kind of can you answer how it compares to, say, cetacean intelligence or even primate? Perhaps that's a
Um,
question for our next teacher.
well, so I don't know exactly how you would measure the the brain itself and compare the intellect that way. But in terms of problem solving, I do know that octopuses tend to be extremely intelligent as well. The one thing that we've struggled as researchers to understand is the sense of coordination between multiple octopuses, which I think is what kind of bumps cetaceans a little bit ahead intellectually. Um, and the other thing that I think is interesting about octopuses is that they tend to be more reactive than to be proactive when it comes to planning certain things. So, for example, the memory of a cetacean is long enough that they are able to make plans for the future, whereas octopuses might struggle with that a little bit, and that might just be due to brain size or to some other phenomenon that I'm just not as familiar with.
We saw, you said something about checking out Voices of the Deep.
Mhm.
What website is that on?
So the Voices of the Sea. Do you guys still see my PowerPoint by chance? Let's see. Yeah, this one. So this is Voices in the Sea. I did try and make a hyperlink, and I can send it to Sean to share with you guys if you're interested. But it is a repository that includes many different vocalizations of different animals. I'll see if I can't share the actual website on Zoom as well. Let's see.
Thank you.
Yeah.
All right.
And
Oh, one more.
can I want to ask one more thing
Okay.
while I'm thinking of it. Is he gone? Is he still there? Yeah. He's still there. Humpback whales and whale song. I remember hearing that different groups in different parts of the world might have dialects. Is this something that rings a bell?
I'm sorry, they might have what?
Dialects in their language and their song? Like, it's similar but different?
Like
Yeah,
an accent,
yeah. So-
Sean?
Like they have, like languages for humans, different.
Yeah, and that's one of the things that I think is very fascinating about vocalizations in general is that there have been many studies where they've played back orcas from one side of the world to orcas on the other side, and they have absolutely no idea. And then they like minimize the distance between the two, and they still might not have any idea. And so there is very clear indication that there are localized dialects exactly for different marine mammals. That's kind of what I also found so captivating about the study that Dr. Garland did with the humpback whales, is how that language seems to move and transmit itself across the South Pacific Basin. Is we have this animal right here, which is currently captured on on screen, the humpback whale. Um, like I said, their songs can last for hours, like upwards of I think 4 hours. And we see how that song changes over time, over a decade. But they add like little bits to it, subtract little bits. It's just very interesting because cultural transmission like that doesn't occur often in nature. In fact, it rarely occurs, if at all. So it's yeah, it's very, very smart animals.
Okay. Thank you, Nicholas, for presenting, and thank you all for coming. Have a good night.